So what are the applications that is actually important for higher mathematics courses is the basically understanding of the vortex vector field is related to understanding of the vortex field in the vector field. We actually computed this in the back in section 16.3, and so this vortex vector field has curl that is equal to 0. So curl of this vector field is equal to the to 0. This is nice because basically, even though this vector field is not conservative, we also showed that the field is not conservative. So even though we showed that this is not conservative, what we can do is to use the Green's theorem to basically figure out one of the line integrals using the other line integral. So let's say I have a random line integral C, and I want to find f dot dr of C, basically, over C. And then let's assume it's a counterclockwise direction. What we did before is that we actually computed the line integral over a unit circle before in the clockwise direction. So because it's clockwise, I have to put in a negative sign, CR, that's in the unit circle, dot dr, so both of them are counterclockwise. And then according to Green's theorem, this is supposed to be equal to curl F in Z direction, dA over the region D. So again, C is completely random. It just includes the origin. And I already have computed this line integral, and I know this line integral is going to be 2 pi. And now I also know that curl of F is a 0 vector, so in direction Z is still 0. This means that any random line integral that includes the origin, basically, is going to be equal to the line integral over the unit circle, which is equal to 2 pi. And that's very helpful in some of the higher mathematics problems, basically.